my name is Janine Crownover, and I will be walking you through a demonstration of connecting, profiling, and masking an Amazon Aurora PostgreSQL database using the Delphix Masking engine. As you can see from my screen, we have the Aurora PostgreSQL database in the US West 1 region, connecting to the Delphix engine on-prem. It's actually on my laptop. And the Delphix engine using port 5432 and using a JDBC connection will be able to reach into that Aurora database, scan the dictionary, determine and profile sensitive data, and then run a masking to mask it. And this should take about 10 minutes. It's very quick, but ideally at the end of this you should be able to easily connect to a Postgres database, run a profile, and get your masking job complete. So just to get started, I want to show you my Postgres database there in Northern California region, US West 1, and then actually my endpoint and my port of 5432. These are two important information as we connect through the Delphix masking engine. I'm going to go ahead and log out and then log back in just to make sure I have a clean start and I haven't timed out. And then I'll start connecting. So right now I have an environment, Postgres demo, but within that environment I really don't have any connectors or rule sets set up. That's what we're going to do today. So I'm going to create a connection, and the database type is going to be that Postgres, and it's just using a JDBC. I'm going to call this post demo. Schema name is public. I've created these objects in the public schema. Database name is simple Postgres. And then this IP address, I always need to cut and paste. I never try to type it in myself because I will be wrong. And the port, I think it was 5432. The login ID is going to be Postgres, and then my password. Test my connection if I typed everything right. Oh, probably typed something wrong. Don't do that. Test it now. There we go. I want to save it in the desktop. Save it. Okay, now I saved the connection. And then when I actually go to bring in the rule set or create a rule set, the rule set's what I use when I direct the profile. When you connect to this database, use this rule set that I'm going to give a name for, and use that, which will include the different tables that I might be using and how many, which connector it's going to actually connect to. So we'll call it Postgres rule, and I got my, I guess that's my demo. Yes. These two tables come in. Obviously, if I had more tables in the public that this user had access to, you would see all of them. And I'll go ahead and save that. And it's saving. And while it's saving, I will go ahead and then create my profile job. And I'm just going to call this Postgres profile. Multi-tenant would be if I'm using this in conjunction with the Delphix virtualization engine. And I don't have any number of streams. Again, this is a simple demonstration. And if you have a large database, you would want to multi-thread that. Profile set, we're going to go ahead and use the HIPAA. And I'm not worried about any of this. I'll go ahead and save those. Right, and I want to double check that my rule set, yep, it's saved. And I'm going to go ahead and run the profiler. So while I'm running this profile, it's reaching into my Postgres database, looking at those two tables, all the columns that may be associated to it. And it's going to tell me which ones they feel is actually considered sensitive. And if you can see, it found an email, first name, last name, phone number, and they found that all of these are sensitive and that we have algorithms set up for those. Now, you've seen my other demonstrations. You can see how you can actually have them identify an email in a standard secure lookup algorithm or algorithm you want to use with it. Very similar on the policies. But what I wanted to point out here wasn't so much that, it's basically done the same thing, but look at this, right? It's gone in, Paul Per's first name looks a little bit different than first name, but it comes out with the same first name. It's able to use a little bit of intelligence, reach in there, do some expression and pattern matching for that data dictionary, and say, look, the expression has some sort of first name, it looks very similar, so we're going to be appropriate. But we're not limited to this particular set, right? We can modify it. So for instance, if I'm not interested in zip codes at this point, I can just clear that out. So even though it provided these samples, that's nothing I need to, or I can add more if I wanted the policy person ID actually mapped, I can do that as well. So now I have my inventory set. Before I actually get started on the masking job, I want to show you what I have. So I have, within that account manager ID table, I have a first name, and then within the policy person table, I have a policy person first name, and I'm just showing you that they're the same. In some instances, George Foreman, now we have Christine Foreman, and you'll see Christine Bartlemage, right? So different last name, but I would expect that this first name, Christine, would be masked identical regardless of the last name, and the last name, things that, and then the emails will be the same. As you can see, they're the same here. So very simple. So let me go and create from my masking engine the masking job. So I'll go in, I'll create mask Postgres. The masking method is going to be in place. On the fly is left for our file masking. Simple number of streams, number of threads, keep it simple. This is a small, very demonstrate database. But we can, if we needed to, if we had a billion row records, we can do our commit size at 50,000 or 5 million, whatever you might feel is adequate for your batch job. And then we would also have PostScript if you wanted to just disable all triggers and disable all foreign keys, or only select foreign keys, whichever it might be. You can run those scripts as well. I'm going to go ahead and save this job. Oh, what did I forget? Oh, my rule set, sorry about that. Now I'll save the job. It's not going to let me make a mistake. And I'll go ahead and run that. Once the job is complete, you'll be able to see, go into my Postgres database here. Once this job is complete, still running. Again, this is just on my laptop, so I would hope that a larger database would complete. Okay, there it is, complete. And if there were some problems, there's always the log file that you can go take a look at if there's some issues where it didn't complete successfully. But this one appears to have completed successfully. If I were to run that SQL statement now, you can see things. George is now Kit, Christine is now Cloudy, and then last name Clouds, Christine Cloudy, so they kept the first name identical. If I go into my sample here, Christine was Bartlemage and Foreman, and now that person is still Cloudy, but it's Scarborough and Clouds. So things have changed slightly. Also taking a look at the database, date of birth, 12/23, that actually had a change as well, where everything else I was just showing you was integrity is maintained through the different changes, but then you can also see that there was a birth date change at the end. And obviously the phone numbers changed as well. And that is really all I have in terms of my demonstration. Thank you.